Hello from Northern Nevada. My name is Jenny Hemsath, and I'm going to do a demonstration of an activity for static electricity. It's called the electrostatic bubble soap bubble experiment. I want to do this for grade 3. If you have any suggestions, please let me know. I think that this would work well for this age group. I kind of went back and forth a little bit on it, thinking maybe it would be for older students. But the more that I worked with it, the more I thought that grade 3 would be fine. The materials, hopefully you have in front of you. I do have the worksheet, which is on electrical charges. Students will count the positive and negative charges so that they have an understanding of what's going to make things come together or repel each other. We also need an empty plastic bottle. I chose the plastic bottle versus a balloon because it seems like there's a lot of experiments that already use balloons, and so this is just another way of showing students that you can create static. We also need a mixture of soapy water. I just used a Dawn dish soap, squeeze a little in there, put a little water and mix it with my straw. I chose not to use the pre-made bubble stuff because I thought that this would probably be more cost efficient. Also, when you use the bubble on your surface, you're going to blow a bubble rather than create it with a wand in order to do the second part of the experiment where you're going to blow a bubble inside your bubble. And you also will need a little of this mixture on your tabletop surface to make it work. Let's see. As far as the materials, I thought that students could bring in their materials. They could bring in their soda bottle, their straw, or you could provide the straws. But the Tupperware containers kind of make them participate in getting all of the materials. They would also need their science journals and pencils to record their observations. The next generation science standard that I chose for this is 3-PS2-3. Ask questions to determine cause and effect relationships of electric or magnetic interactions between two objects not in contact with each other. I made it a little bolder font here for why I chose this. The clarification statement of examples of an electric force could include the force on hair from an electrically charged balloon. I also made a bold font for assessment boundary. Assessment is limited to forces produced by objects that can be manipulated by students, and electrical interactions are limited to static electricity. Again, if you have any suggestions here, I would appreciate that. Sometimes I have a hard time aligning the standards with a lesson or activity. Okay, so for our procedure, I apologize for the video quality. This is pretty much the only way I can do this. It may be hard for you to see my bubble that I create. Hopefully I'll do the best I can. So we run through the procedures. I already discussed that students could bring their own container from home. You could prepare the soap mixture ahead of time. Maybe somebody could help you out, a parent volunteer or something. This could be an after lunch activity so that you have time to do that. I would go over safety precautions and classroom management ahead of time because you don't want your students to be drinking this, obviously, which is kind of funny in a way because when I first looked at this activity, it called for you to suck in some of the liquid before you blow your bubble. And I did that and I drank it twice. So not a good idea. My husband suggested, well, why don't you just dip the straw in there, stir it around a little bit. I thought it wouldn't work, but it did. You can make your bubble that way. So let's see. Safety precautions. Eyewear, protective eyewear, I think is a must because if you do have any splash or whatever, you don't want soapy water getting into the eyes. let's see, use only the amount of soapy water necessary. We don't need a large quantity that'll be easier to spill. Do not drink. Apply the water only to the area that you're going to be working with. And only one student will use the straw to create the bubble. That way kids aren't, putting the straw in each other's, one kid to the other or whatever. Also, whoever's not making the bubble can be the one to do the static on the bottle. Okay. So I did put in a little bit of a background there that for teacher understanding to help with this activity so that students know what is happening and why. Teaching strategies, direct instruction. I would go over how this is to be performed ahead of time, also explaining why, somewhat why, because they actually they need to be making their observations. So with the cooperative learning, the second teaching strategy that I have there, they'll work together doing the procedure and then also saying what they think is happening, what they see. I think it would be helpful to have a little bit of an understanding or teacher discussion prior so that they can make those connections about the protons and the electrons and positive and negative, and that way they'll have something to write. This is what I think is happening when I do this. Integration in other subject areas. I think that history would be good. Who discovered static electricity? How did this happen? How did it come about that this was discovered? And art. I thought this could be something where you could incorporate making a poster that shows what is happening. I think visuals are great. They always help me, so that's why I thought it would be good to incorporate that. Let's see, I did make some extra notes here regarding that. I thought that also, it's not really an extension, just an afterthought though, that the items, the plastics that are brought in for this activity could be collected at the end of the activity and used for recycling. This could become another discussion. You could go into, or science discussion of pollution and different things like that. Okay, so I think we will go into the procedure step by step here. Hopefully I can do it to where you can see it, but that's why I'm really glad that you have the supplies and can do it yourself. This is not something that I had seen done before, so I was excited to find this activity. I just brought a tray so that maybe I can hold it closer to the camera in order to show you my bubble. Let's see here. So first of all, I've already poured a small amount of water on here, of the bubbly mixture. I'm going to do it again just to make sure that I can make my bubble seal on there. I'm going to stir it up a little bit and then just blow onto my wet surface and create a bubble. I'm not going to make it very large. I've found that if you make it too large, you can't create, or you can't make it move as easily. You can make it be misshapen, but you can't get it to move across the surface. So one student will have done this, have made the bubble, and the second student can be sitting there doing this, create a lot of electricity. And then you just simply hold the bottle near, but not too close, because you don't want to pop your bubble, near the bubble, and you can see, hopefully you can see, that it will move. If I go that way though, then gravity's going to affect. So yeah, I'm worried that you guys can't see my bubble moving because of the quality. Oh, there it goes, and then it popped. So they may have to do this several times where they recreate their bubble if they pop it. That's why I thought that it would be good for only one person using the straw. The second part of this activity, they will have to have a bubble, and then they will take their straw and put it inside the bubble to make a second bubble. Oh, two of them split. I'm just going to pop my bubble here. So I'm going to try that again. There's my bubble, and inside. Oh, that didn't work. That just made my bubble larger rather than put one inside. Okay, so now I have a bubble with a bubble inside of there. And students will again try this and see what happens to the bubble inside. So if you notice, so I know you can't see mine very well. Oh, actually they split. That's not what was intended here, but what students will see is that the bubble on the outside will still change shape or move, but the bubble inside doesn't do anything. It stays perfectly right where it's at. Unless, of course, it splits like mine did. And then they'll have to pop that bubble and recreate so that they can have a bubble inside a bubble. So let's see here. I need to look on my procedure. I added some notes here, probably some things that could be vocabulary words, triboelectric effect, and Faraday cage. That's basically what is happening with the bubble within the bubble. The bubble within is protected. Okay. Let's see here. I'm sorry, I just want to make sure that I'm not missing anything here. Yeah, I thought that as far as an extension, I didn't discuss that yet, that students could perform research and find out what is a Faraday cage. Find that information, come back to school and share with their partner what they found. I also thought that a good extension, which is kind of fun and would be something that kids could do with their parents, is to make your own electricity. I found this activity also, and I thought it would be really fun to do, but it actually is kind of difficult, so I thought that probably would be a little frustrating in the classroom. And it's where you have a plastic comb, I can't see very well because of my lighting, and a fluorescent bulb. The main reason that I thought that this wouldn't be good for the classroom, but it might be good at home, is because I didn't have a wool scarf. I tried doing this on my hair to make some static, and there just was not enough to make this light up, because you're supposed to be able to get some static going on the comb, touch the lamp, and the lamp will flicker. At first I thought that was baloney, that it wasn't going to work, and then I used the cat. So that's why I said in my lesson or my activity, I didn't mean to be funny, but it really worked. Pet the cat for a while, get some electricity going, and it will work. It will flicker. I was very excited. So I thought that that would be a good extension activity to try at home with parents. That's pretty much the activity. Hopefully I explained it. I know that my lighting is really, really bad. But if you have any questions, please text me or email me. Suggestions, anything like that, 775-901-2881 is my cell phone. So I think I will wrap it up, and I'll wait to hear from you. Thank you.